Thank you so much for attending and for listening for the online and offline audience. And today we have Oscar Skans, who is going to talk about heterogeneous earnings impact on job loss across establishments, markets, and workers. And this paper is basically relevant not only from the policy perspective but also from the statistical point of view, where he uses more modern methods like GRF to estimate heterogeneous effects. And Oscar is a professor at Uppsala University, and he's currently visiting Stockholm School of Economics. And yes, thank you so much, Oscar, for joining. And please, the floor is yours. And yes, you could ask questions on the way as well.
Okay, thank you for inviting me. This thing is on Teams. I'm a little bit unfamiliar with the technology here, but I hope it will work. If you have any questions, just speak out, and then I'll be happy to try to address them. So this is joint work with a bunch of people who are either are or were at Stanford, or who are at different institutions in the Uppsala economic environment. So this is a paper about the earnings effects of losing your job. So essentially what we do in this paper is to try to identify things that characterize their workers or their environment that will predict whether they will be able to bounce back fast or suffer large losses if their employer essentially fires them because they are closed down. So we use displacements due to plant closures to identify these effects, and then essentially we compare the earnings changes of these people who are exposed to these types of events to a matched control group, which is something that's been done hundreds of times in this literature. The novelties here are essentially twofold, I guess. So one is that we characterize the workers and their markets by very, very rich register data, and then estimate the effects in a way that allows us to see how the effects vary across groups, and to handle the fact that we have so many different dimensions, we use the GRF. And I should say that this is a big group of people working on this paper, and I'm sort of more on the applied side. So my interest here has mostly been to think about how to be able to make sense of these types of estimates and to extract insights that are useful and important. And I'm happy to take questions on anything, but there are aspects where I may be less, more or less able to answer. But please interrupt me and ask questions along the way. So essentially, why do we study this question? Well, essentially, if you think about it, many of the things we like in life, in material, in the material dimension at least, comes about from a process of creative destruction, where old firms and jobs and ideas are destroyed by better alternatives. And this is something that generates very subtle and smooth benefits to society, but at the same time, there are very distinct losses for people who lose their employment in this process. And this has been well documented, so people lose a lot of their earnings, and that had all sorts of additional consequences in terms of divorces and substance abuse and whatnot. And of course, policymakers are fully aware of this, so they have most countries put up a long list of very costly social programs to mitigate the effects here. Things like training programs, unemployment benefits, and stuff that you do after people lose their jobs. But also a lot of policies of different types. So can be regulations in terms of employment protection. It can be firm subsidies in terms of furlough schemes or similar, or subsidized training programs for employed people trying to prepare them for structural change. But since these policies tend to be costly and or distortionary in other dimensions, you want to sort of keep them down to a minimum and target them to the part of the economy where they're mostly needed. And you can see that easily if you look at the policies, that there have been attempts like this. But sort of a general question when you start building these types of policies is to know who we should really target, who are most important for us to help, and who will manage on their own. And this is sort of where we're trying to go with this paper, to give policymakers a better foundation for answering these kind of questions. So what is it that we do? Well, we study how earnings evolve after plant closures, and we compare the outcomes of the people whose employers shut down to the earnings of other workers that are matched. So they look similar before. And then we use the GRF to handle the heterogeneous effects. So we essentially estimate treatment effects that are allowed to vary with observables. And as always in this setting, it's important to keep in mind that we will claim that we estimate causal effects for each type of workers, but the differences across types that vary with the x's are not necessarily causal. So if we find larger effect for people with less education, it doesn't mean necessarily that's because of lower education, but it's still going to be a difference in causal effects for those with low education relative to those with high education. Okay, and then what we do is we study the effects and see how much heterogeneity there is. We try to characterize where the heterogeneity is coming from, and then we discuss different types of policy targeting, both how you should do it, and we actually also study a little bit how that it's currently done in the setting that we're analyzing. And we also analyze the relationship between heterogeneity in these effects and other related income processes. So why do we use these plant closures? It's something that's been done a lot in this literature, precisely because it's something that we can identify in the data that where someone loses their job, not because they started drinking or did something stupid, but because of something that happens on the demand side. It gives us a well-identified timing. And the data will also include people who just hop onto a new job without an intermission, which is important in this setting, because if we would, for instance, look at people who become unemployed, that's kind of then losing 1/3 of the sample that are the people who actually don't need policies. So it's good to know who those people are. And of course, these closures happen across all sectors and regional labor markets. So it gives us a lot of events. And there's a huge literature doing this for at least 30 years. And in most of these papers, they actually study heterogeneous effects, but typically cutting it then by, one or two variables in an ad hoc fashion. And often actually this stuff has also been theory motivated, so that sort of put the emphasis on certain dimensions of heterogeneity. Whereas what we're trying to do here is really to put into our model everything that sort of, it's a bit fuzzy, but from our perspective, that policymakers or caseworkers could use in principle to figure out who would be someone who is likely to need more or less help. So it's going to be rich on characteristics on industries and locations, but also on workers and on firms.
Sorry, can I interrupt you here? Just
Sure.
One quick question. So basically, should I think of a layoff as a binary variable here, where
Yes.
you take some period, for example, and you track individuals over some years, or you use some kind of approach where it's a dynamic? dynamic.
The event is going to be a binary and discrete one. So the way we set up the data is that we start from the event. So we define the events when, and I'm going to say something about that, but a firm shuts down. And then we take all the workers who worked in that firm in the year before. And those are the people who are affected by this event. And then we compare the earnings trajectories of these people before and after to a matched control group. So that's the way. And the difference between those two will be our causal effects of this event.
Right. Thank you.
So, and the way we do this is using data from Sweden, which is very rich on various things. So we're using, for the most part, closures that happened during period 97 to 2014. In 2014 is 10 years ago, and it has really two reasons. One is that we want to be able to follow the people afterwards. And the other one is that we've been working on this for a few years already. So that's that. But I'm going to show you that the stuff we get out of this actually turns out to be very useful also for looking at things that happen after this time period. So the data allows us to characterize people based on their demographics, their family status, their general and specific human capital. So essentially things like their education, labor market experience, their previous earnings. You can characterize the job characteristics, so the size of the firm, the types of jobs you were doing, and your earnings within that job. We characterize the industries based on a number of things like the wage level of the industry, how dynamic it is. So whether there's a lot of churning in the industry, as you could think of, say, restaurants as opposed to manufacturing, which has much longer employment spells. And the trends of the industry is both a long run trend and the short run thing. And then we characterize the locations based on whether they're, the population density, the industry structure, the unemployment rate, and things like this. So the idea here is to put in things that you would think from existing research and, economic theory would matter, and which is kind of sort of, I wouldn't say easily observable, but potentially observable either by a local caseworker or by a central policymaker that wants to design policies to help people. And essentially what we find is that there's a lot of heterogeneity in the effects of losing your job. And the model is able to capture quite a lot of this heterogeneity, and the prediction seems to work out of sample within the time period, but also for events that happens later, as I mentioned. Now, it is complex in the sense that there is a very large set of variables that help predict this heterogeneity. So it's not easy to approximate things with one or two variables. And one of the things that's been discussed a lot in this literature is whether the heterogeneity comes from just the type of firm that closes down, or whether there are other things. And we show that there's a lot of heterogeneity both within events and across events. So within events means that there's heterogeneity across people who lost their job from the same firm. So it's not all about the firm. And this is kind of important because the interpretation of the firm part has often been that, okay, people lose money because when they are fired from a firm that pays higher wages. And then when that's gone, they're sort of back to earning, some kind of random average wage or something like that. But that doesn't seem to be the full story. We also show that the people who suffer the most in terms of these effects are people who have a higher than average displacement risk on average. We also show that the effect, which we predict based on the short run effects, also are very predictive of longer earnings losses, longer run earnings losses. And these are also people who have a worse outcome without the job loss. So in that sense, it sort of accelerates inequality. And that, again, is a reason for why an additional reason for why you may want to have policies to target these people. And essentially, if you try to somehow simplify the heterogeneity here with the set of few variables, essentially what you would like to combine is age, which is super important, and the job content. So essentially, the algorithms tells us that focusing on old workers in routine jobs is kind of the combination that's getting closest to the full model. And then we also have some results on what actually is going on in Sweden. And if I have the time, I'll go there. Good. But let me just give you a sense of the data that we're using. So we're starting from Swedish registered data that covers the full population, so everyone and all the employers. And we're using data at the annual frequency. And the basic data goes from 1985, but we use the first years to characterize the workers' employment history, and then we look at the events in this period from 97 to 2014. And essentially, the way we construct this is what I briefly said before, that we define everything in what you think of as T-1, so the year before when the closure happens according to how we define time here. So we require that people have worked there for at least 2 years. It's because a lot of people actually just go in and do move around a lot. And for them, a closure will not matter. It's like people doing internships or summer jobs or whatever. So this is kind of standard in this literature, I would say. So we require that people work there at least 2 years, and then we characterize them in this year before. And these are the workers. And then what happens to the establishment is that it was in sort of full operation in T-1, and it had some operation in year T, but it didn't exist in T+1. So the somewhere during year T, it ceases to exist. And then we remove what's called false closures in this literature. So that means that when a mass of people is going to the same firm, the reason why people do this is because you don't want to conflate a closure with what's in effect a merger or something like that. Now, the control people here are people that are identified in exactly the same way, except the only other requirement here is that their establishment did not shut down until T+1. So it's kind of the reverse. Otherwise, they're constructed in a very similar way, and that's that. So we have, doing this during this time period, we get 22,000 closure events and around 200,000 displaced workers. And then we use like an old school standard matching thing to construct the set of control workers here. So we just because we don't want to work with just, the data is very large because we have everyone in the economy every year. And we want to kind of reduce that to the people who look similar to the displaced. And we match 3 workers for every displaced. And the thing which is kind of non-standard, I guess, is that we match without replacement, because we want to ensure that that we have an independency between different events, and I'm going to come back to that. Okay, so the variables that we use to characterize the heterogeneity here, they're around 50. And I'm going to show you very briefly what they are. If I would talk more about how we constructed the data, we would have to spend the rest of the day here. But it's essentially capturing things like demographics, family status, whether you move sort of past geographical mobility. And as I said, maybe I'll just skip through this. Yeah, so this is kind of standard type of results graphs that people do in this literature. So now we're still looking at the average effect. So if you look at panel A on the top left, this is the impact on earnings. So it's earnings relative to what you earned before the the closure. So you can see there's this clear gap and then a recovery. And there's what's year 0 here is the year of displacement. And you can see it's like halfway, and that's because something happened during that year and can be, but we're not going to focus on that one. Our focus is going to be on the difference between t-1 and t+1. So between 0 is -1 and 1. So that's kind of what we're going to use when we look at the heterogeneous effects. In panel B, we look at employment, and in panel C, we look at the earnings conditional on being re-employed, which is a little bit of a funny thing to do because, of course, the original balance that you had from the matching stuff is completely destroyed because of the employment effects. And if you look across time, the samples are going to change. So in particular, if you think of a world where there are heterogeneous effects, those kind of conditional things where you sort of conditional another outcome, it's going to be something that is going to be very hard to interpret. The stuff on the bottom in panel D is a more non-standard thing. So here we're showing the distribution of changes in the earnings amongst the displaced and the matched controls. So essentially, what you can see is that there's a lot more negative changes in the displaced group. I mean, even amongst the controls, there are some people who maybe lose their jobs for other reasons, even though their firm continued to operate. And, people do all sorts of things in their life. So one here would be an unchanged earnings. But what you can also see that it's not a shift of the distribution to the left, but it changes the shape of it. In particular, there's a lot of people that doesn't earn anything during the full year. But the fact that the distribution changes in terms of the shape means that you have heterogeneous effects exposed. So the question then is, can we predict this to some extent with the data?
Can I ask you one more question regarding, so if you go back a little bit, the previous plot. So one more thing I see here, maybe this is not the crucial point here, but like if you look at panel A and panel C, so essentially we do see that average treatment effect on the total earnings, basically this is non-employed plus employed, drops substantially, and then the slope is, so basically the increase is much faster when compared to panel C. So employed workers do not catch up over time as fast as so this is driven by non-employed, right? That's my point. So basically the conclusion from panel A and panel C would be that non-employed individuals are able to overcome or catch up with the earnings faster than the employed ones, and could that be because Sweden has very nice, supportive schemes for these workers, or why do we see such a difference?
Typically, the way people interpret this is that you see a return in terms of employment, as you see in panel B, but then sort of wages once you're employed, they're kind of permanently lower, and this would be now the idea of losing some of the rents you had in your previous job. That could be from various things. Maybe you had a lot of specific human capital in that job, but that disappears. But I would be, as I said, very cautious when interpreting panel C, because as you can see from panel B, there's a gradual change in the composition of people who are employed, right? And even if you would look at just the control group, everyone by design, everyone is employed in year 0. But over time, of course, that goes down also in the control group.
I see.
So you have all these kind of changes in the sample that you analyze, which, I mean, you do a matching from the start to get a balance between the treated and controls, but that balance disappears once you start looking at the selected sample that actually are re-employed. So for that reason, we will only focus on those outcomes that you can measure for everyone, because otherwise you need to have a model in mind for the selectivity back to employment also. And even if you have that model, you still want to take, when you look at things across time, you need to account for the fact that the samples are changing. And if you think that effects are heterogeneous, then the average effect of a sample that changes over time is not very informative.
I think Andrei has a question. Are there any possible problems of endogeneity or any type of confounder bias?
course. So this is you know, so the what we do to try to construct sort of a design, the causal design here is based on the matching thing. So essentially that we construct people with very similar characteristics, and then thinking of, you know, the bad fate of the firm as something that's exogenous, conditional on that. So that's what's done in this literature, and you can see from the time profiles of these things that it makes sense. But of course, in particular, maybe if you want to look in the longer run, you could start to worry that maybe there are unobservables here that would be related to the so that's a hard nut to crack with these kind of things. But that's yeah, this is what we do. What we have done a little bit is to play around with things that we don't use here. Like say we had some test scores for a large population of these people. You can measure the cognitive and non-cognitive skills, and it seems to be perfectly balanced, even though we're not matching on that. So people that we get out here through our matching strategy seem to be very similar. Okay, so turning to heterogeneity, but okay, yes. So that assumption, we're going to maintain that assumption that we can interpret the stuff as causal in line with the literature. But it's if you're a true skeptic, you should really keep that in mind. So okay, but what we do next is to look at heterogeneity, and we start by doing the sort of the simple thing, which is essentially estimate the effects of losing your job on the earnings 1 year after, and just interact that effect with characteristics, and doing it one by one in a separate regression, and then just showing those interaction terms, just to illustrate what the data looks like. And what you get is this. So now these are the indicator variables that we have in the data, and it gives you a flavor of some of the variables that are there. So it's a gender dummy, so there are no differences between men and women. You can see that the immigrant dummies to the left, it means that immigrants on average lose more if their jobs are destroyed. And then there's all sorts of things. You can see that manufacturing has a very low, people who are displaced from manufacturing lose a lot more. On the furthest down, you see the people who are in sort of publicly funded jobs, they lose less, and so forth. And then we have a lot of variables that are not indicator variables. So these are all sort of continuous variables that are standardized. You can see at the top that the older people lose more. And if you go through these, they all kind of make sense, both in relation to the previous literature and what you would think of from economic theory. And I think here, you know, just our basic understanding of how the labor market works. But you can also see that there's a lot of stuff going on. So, and essentially you could write a paper or 10 about each of these estimates, and people have done that. But if you want to go to a policymaker and say, who should you focus on, it can be a little bit hard to summarize these kind of things. And that's why we think it's useful to estimate this in using one model that can account for all of that. And for that we use the GRF. So essentially now, so essentially you probably all know better than me how this works in practice, but essentially what this algorithm does is it estimates these causal effects and then try to predict how it varies with the exits by sequentially splitting the data to find combination of exits that maximize heterogeneity in treatment effects, and then doing this using subsets of the data and only allowing for a subset of the variables in each split. So you get many trees, and then you combine these trees to get what's called the conditional average treatment effect, which is a very intuitive thing. It's the estimated treatment effect as the function of the characteristics of the observation. So the way we do it here is that we split the data in 5 folds. So it means that we use 80% of the data to estimate the model and use the prediction from that on the remaining 20%. And then we iterate across these 5 folds. So that means that the predictions will always be imposed onto observations from another part of the data set. So you can think of them as being out of sample predictions. Now, what's really crucial here is that we cluster things by event. And by event, that means a closure event and all the people who were involved in that and all their matched controls. And this is also why we match without replacement. So because that way we ensure that the controls are not showing up in multiple folds. And this is to ensure that we have independence between the different samples. So when you cluster in this setting, which again, maybe most of you know this better than me, it's different from when you do it in sort of standard types of analysis, where it's mostly about how to estimate the standard errors. But here you really want the samples to be independent. So you don't want people who are exposed to the same event both to be doing the prediction and then to evaluate. To start. Okay, so this is the way it looks like. So this is the distribution of the conditional average treatment effect. The vertical line is the average treatment effect that you saw before. Again, everything here is equal to 1 stuff. So you can see this rate. We do not predict that there are any types of workers who benefit from their firm closing down, which sort of makes sense in the sense that people are not hostages in these firms, so they can move if they want to. And you see that there's a lot of people with relatively minor losses, and then a long tail to the left with consecutively sort of worse outcomes.
Sorry, Oscar. So,
sure.
So this was pooled over time, right? Like this is not a distribution within one period, but just over all periods. Okay. Sorry.
Oh, that's a good point. Okay, so what we do then is to split the sample into deciles, and these deciles are then constructed within these folds to make sure that there's nothing funny going on. And then for each of the deciles, we estimate again the what we call the average treatment effect, which is just the differences between the displaced and their matched control groups, and that's the green dots. And then we also the model, the algorithm also gives us these AIPW scores, and that's called the doubly robust here, and you can see it's identical to. So what that means is that there's balance on the covariates. That's our interpretation. And then you see the K line, which is now a flatter one, and what that means is that when the distribution you just saw, it works as a good predictive tool to figure out who are going to have the larger or the smaller losses. But actually, when we go back to the data using these predictions, we see that the differences in effects are larger than what you just saw in that histogram. So what we're going to do throughout is when we talk about magnitudes, we're going to use estimates that are done in cuts of the data that are motivated by the output of the GRF. So the GRF only gives us, so the way we do it, it only gives us the cut of the data, and then we take those cuts of the data, and then we estimate things in those cuts. And importantly here, remember that these the Ks are coming from another subset of the data than the ones where we evaluate them.
Sorry to interrupt you again. So this looks like very much what Chernoshukov has been doing, right? Like basically estimating obtaining results from GRF, and then I think if I remember correctly, he clusters this into different quantiles, and then he runs OLS within each quantile. So that's what we're doing, right?
No.
Okay, so it's kind of doubly robust estimation, or Thank you.
Yeah, no, that's thanks. That's very good. So okay, so there's a couple of robustness checks that I can skip, but this one I think is interesting. It's related to the initial question, whether the things are stable or not. So this we did very recently, and I was hoping that it would look good, and in my interpretation, it does. So the training data that we use, it's using closures between 1997 and 2014. So the median year is somewhere around 2005-6. But here, so we stopped at 2014 because we wanted a bit of a follow-up period. But since as long as we're focusing on year one, we can use this data and use the events that happen in 15 or 16 and evaluating. So now we're using the prediction from the earlier years and then using displacements that happen later on. And you can see that it still works pretty well in the sense that the predictions are useful in figuring out who would have large or small losses in those years after. And our interpretation is that the processes that are generating these heterogeneity are stable enough for us to be able to predict what happens in years that are after we estimated the GRF. So that's kind of reassuring to what I think is a legitimate concern a priori, in the sense that you would maybe worry that the things are just specific to the time period when we estimate. Doesn't seem to be the case. Good. Okay, so then we relate these predictions to other income processes. So here again, we have these cake deciles, and here's the probability to get displaced just using the propensity scores from the initial matching. And what you can see is that the people with the smallest effects are also having a risk of displacement that's around 2/3 of those with the largest effects. So in that sense, if we would target policies to the people with the largest effect, it's also people that have a higher risk of being exposed to this negative treatment. So that's, I think, it's essentially important from the perspective of applying this. Okay, so when we look at the long run stuff, so we trained everything on what happened in year one. We re-estimated the model, instead training it at what happens at year 3, and the correlations are like 0.85 of these predictions. So it's very close. It's not very different. So it's the same people essentially. And you can see that here also, if you look at panel A, the blue line are the decile with the largest effect, the red line with the smallest one, and the black one is the sort of 10% straddling the median. And you can see that, yes, we have these largest effects in those that should have it. But then if you also track them over time afterwards, you see that these things are also related to persistence. And what we see on those other graphs is just showing separately for the treated and the controls. And here you can see that in the group that have the smallest effect, it's not because the control group is also doing poorly. These are people where the control group is actually doing very well, but the people with the small effects are kind of almost bouncing back to that early on. But whereas if you look at the panel D, you see that the control group here actually has a much worse counterfactual or much worse outcome, but it's just that the people who are displaced in this group, they're actually suffering even more. Sorry. So again, this paints a picture where these events seems to accelerate inequality in that sense. It's the people who have lower earnings before that and without the event that actually have the largest negative effects. You can also see that these three groups actually differ in terms of both the level and trend before they got displaced, but they're always perfectly matched towards the control group. So that's kind of reassuring in terms of the identification. Okay. So one of the things you can think about, of course, here is what is it that drives these predictions? And here we're just showing the differences between the top and the bottom quartile in terms of characteristics. And it's essentially painting a very similar picture to what you saw in those simple interactions early on, which is in a way maybe unsurprising. But you can see that, and here we kind of sorted them by the magnitude of the difference. And what you can see is that we don't have time to go through all of them, but on the top you have age, and on the bottom you have schooling. So in terms of the continuous variables, it's age and schooling that are the two best predictors. And then on the other side, you see again manufacturing and the industry and some other things. So we tried to make sense of these by sort of focusing on age and schooling first. And this is a graph that some people find horrible and others like. But essentially what we're doing here is just splitting the data in 80 groups by 10 age deciles and 8 groups of schooling. And then for each of these groups, we estimate the treatment effect. So there's no machine learning at the top, at the top, at least on the left-hand side. And on the panel, in panel A, panel B, we redo it with the AIPW, but doesn't change anything again. But essentially what this picture, although it's a bit noisy because the individual groups start to be small here, is that if you increase age at a given level of schooling, you get larger effects. And if you reduce schooling at a given age, you get larger effects. So because you can see it's really on the diagonal that it goes from blue to red. So it means that essentially they are sort of independent predictors here. And what we do at the bottom is within each of these 80 cells, we pick out, we ask the algorithm essentially to pick out in panel C the quartile with the sort of smallest predicted effect. And in panel D, it's the quartile within each cell with the largest predicted effect. And then again, we go back and just estimate the effects. And what's interesting is that even though age and schooling, you can see if I go back to panel A, the differences are very large here. So if you go to the sharp red, it means that they lose more than 40%, and the bright blue is less than 10%. So, but if you look at panel C, you can see that across all these groups, these are people that do better than the grand median. And if you go to panel D, these are all people that do worse than the grand median, except those that are 26-year-old PhDs, but there are very few of those. So essentially what this means is that even though age and schooling are very important as independent predictors, there's a lot of predictable heterogeneity within these groups. That's the point. And if you look at it in more detail, where it's coming from, it's mostly the industry and the location. And we do this kind of exercise to try to show that really the heterogeneity here is multidimensional and coming from various. It's not like there are different variables capturing the same thing. So that's the same. So again, you should think of the panel C and D as out of sample stuff within very, very small cells.
So these were the probability of like the risk, right? Risk of displacement.
No, this is this is the earnings effects of being displaced.
Right. Okay. So these are okay. So this has heat maps, of course. Yeah. Sorry. The positive.
Yeah. So I mean, everything is negative here. So in that sense, everything is below zero. So everyone is losing, but it's just different degrees of losing. So as I mentioned before, there's a lot of discussion in these types of literature about whether the effects are just associated with the characteristics of the job or the firm that's closest down. And from what we just saw, that seems really implausible, because why would then the older workers lose so much more? It cannot be that they are all in the high wage firms and things like this. But one way to sort of go pretty directly to this question is what we do in the top panels here, which is to split the data in two different ways. One where we just order workers not into overall deciles, but deciles within the closing establishment. Okay. So, and then we re-estimate the model. But because these are ordered only within the establishment, there is no heterogeneity here from across the establishment. So this is like pure individual level heterogeneity. And you can see that there's still a lot of heterogeneity here. So it means that there's stuff about the people that the model can predict who within a specific closure event will do well and who will suffer more. And on the right-hand side is the converse. Here we instead characterize the establishment based on the average instead. And you can see that there's a lot of heterogeneity there as well. And in some ways, it's about as much. But when you look at the cross stuff, it's also capturing, of course, sorting of that there's certain types of people working in certain firms. And also that the firms are located in certain regions and industries. And really that's what we're doing at the bottom. Maybe I will skip through it a little bit, but essentially it's kind of showing that a lot of the heterogeneity across firms that close down really have to do with the industry and the location. So we can play around with that as well using these predictions. So that's kind of nice. So you should stop me if I'm going too fast. But essentially, this is kind of stuff that people care about. And I guess the fact that we see what we see in the bottom, that you can sort of essentially what, okay, so I go through that. What we do at the bottom is to take other events, so other closures that were in the same industry and location. And we use the predictions from those to rank the actual event. And then we estimate the effect. And the fact that you can predict what happens during a farm closure just using other events in the same industry and region, kind of from a policy perspective, is important, because that suggests that you could design meaningful targeting policies by using industry and location, because it's unlikely that you design a policy that will find the right firms, but you can, if you know the firms where the effects are large are in certain industries, you can embed that in your policy design. So that's the point of this.
That's an interesting plot, Oscar. I'll just briefly read the comment. So Andre is asking whether GRF method that we use here is related to causal random forest or variability. And this is essentially the same, right?
Exactly the same thing, yeah.
And then he's asking whether we could use Bayesian extensions in the line of Bayesian trees. Bart, yeah, probably. Maybe I could reply if you don't mind, Oscar, and you could correct me as well. So Bart is it would definitely be you could use it, but I guess typically when it's harder to interpret the prior assumptions, right? What would the prior treatment effect be, because we don't know the effect of lay of prior. So essentially the problem would be here with Bart is that we don't only need to set prior for the aggregate effect, which would be in the general case, if you use Bayesian linear regression, let's say you would just set a, let's say, normal prior for the parameter. But here, because things vary across these different covariates, we don't really know which distributions or which means and variances we should set for these treatment effects across this covariate. So it makes it more complicated. But I mean, in principle, in theory, you could use it, right? So there is no theoretical complications here. It's just where to take these priors from, from what kind of literature, because probably there are studies related to this, but not exactly the same ones.
Yeah, this is a little bit beyond me, so that's probably true. I guess, I mean, we often get the question whether you could use other methods as well, and of course, that's entirely doable. I think that the method that we're using here, at least it makes sense in this. I mean, it's not a crazy method to use here. I mean, it has some advantages, like allowing for a lot of interaction terms, and even from the theory we know that the things should be probably matter in different, so certain of these features will matter in a different way from other things. So you want a flexible non-parametric model. So that's one thing. And then of course you can think of other algorithms that also do embed that. But yeah, I'm essentially, but I mean, so that's important. So when, so and that works fine in a tree-based model in a way. That's good, because you can think about things like you're being in a bad location. Then it's important that we have certain variables that capture essentially the cost of moving. Like you have kids at school. That's not a problem if you're living in a good location where the market is good. It's a problem if you're living in a bad location where so you always want a model that's very flexible in terms of these kind of things. But of course, that can be other algorithms as well. But that's okay. So I was doing what I do when I don't have a clue for the actual answer to the actual question, answered something else. But anyway, yeah. Okay. Yeah, there's this, we're sort of playing around also with the problem is how to make sense of these things in a where you want to sort of extract insight at a higher level than the actual estimates. So that's one nice thing that you can do with these predictions. And here, what we're doing is that we're first ranking the workers within the establishment to get sort of a pure individual level heterogeneity. That's on the x-axis, and then we split the market, so that's the industry times location, by the predicted effects. And the idea here is to look at whether markets matter more for the people at the bottom or the top of the within firm effect distribution. And actually what you see is that it matters much more at the bottom. So essentially, if you are a person that are amongst the sort of top 10 resilient types of workers within the firm, it doesn't really matter to you if you are in a manufacturing firm in a rural town. But if you were a worker, say, at the bottom, maybe you're an old and low school worker, then it matters a lot for the effect if you are in a sort of an urban town working in an industry that's not in manufacturing, or if you're a manufacturing worker in a rural town. So there's this interaction between sort of levels of heterogeneity, or groups of heterogeneity that you can uncover with these kind of exercises.
How do you define these markets? Are they like local labor markets, or are they something else?
So there's essentially commuting zones, that's the regional thing, and then here is interacted with a 3-digit industry. So it's like a combination of an industry and a location. But there's stuff where we do it separately also. It's especially this is this interaction thing, that it's really bad to be at the bottom within if the unit is also in a bad position. That seems to be the case here. Also, you can do it at the establishment level, so you can see if you're low ranked within an establishment where the general characteristics would predict big effect for that establishment, then the effects are just enormous. So, but if you're at the top, it doesn't really matter if it's an establishment with a small or large predicted effect. So it's really this interaction thing. Good. I'm roughly on time. So okay, so what we're doing then in the final part of the paper is to now we're going to use 20% of the data that we didn't use at all in the previous stuff. So 20% of the event because of the clustering. But that's not really essential here. But essentially, you can think about, say that we had a policy that we knew were useful and we wanted to target it. And then, so if we would just take out 5%, 10%, 15%, 20%, or 25% of the sample and then apply it. If it was a random sample, then of course, on average, we get an average effect, which is then the blue line here. And then the red lines are if we would use GRF. And you can see it nicely grows here, which is very nice, because it means that if we took out 5% in this out of this test sample, based on the predictions, we will get a job loss effect of 50%. But if we go to 6%, 7%, the effect in that sample will diminish. So it means that the people actually do have lower effect. Even, every incremental percent that we add dilutes the effect. So that's what you would like. So that looks good. But then you can think about doing this with other types of variables, and these are some examples of that. And we know that age is important, so if we use it, it's going to be way better than a random thing, but it's not going to be as good as the GRF because there's also other things that matter. Then what we did was also to use this kind of optimal policy algorithms from Susan's more recent work to constrain and ask that algorithm. We sort of generate an artificial made up cost, and then we ask the algorithm, given these costs, that is then designed to put a certain fraction of the people in a position where we would like them to be treated. And then if you only could use two variables, or you could only go to a depth of two to define who would be treated or not, what would be the best way to do that? And that's the gray line in the bottom. These three dots are three different cost structures, and all of them end up with this combination of age and routine. So essentially saying that we should treat everyone who is above age, I don't remember exactly, but it depends on which one it is also, but say everyone above age 52, and then take also everyone who is above age 40 if they're working in a sort of manual routine job, which is essentially saying that they would be in manufacturing and being low-skilled workers. So that's kind of should be the frontier of how close you can get to the GRF with a simple rule. So one of the things you can think about is that we looked at, so what we did so far was to look at the impact on labor earnings. So essentially how much money you get from employers. But at least in a country like Sweden, you also can get money from the state if you're unemployed. So the data gives us a measure of disposable income, which takes account of all transfers and taxes. So we can look at the impact on disposable income as well. And you can think of the difference as insurance. So we're using the same model here and the same prediction, the same cut of the data. And the blue stuff in panel A here, which is where you should focus, is what you already saw. That's the effect on labor earnings. And the red stuff is the disposable income thing. And the difference is really insurance. And essentially what this gives us is a rate of insurance at the bottom that's like 70%. And then from the middle and up, insurance that's provided is about 50%. So then you get much less heterogeneity, of course, in disposable income effects. Should be careful here, of course, because it could be that people behave differently because of the level of insurance and so forth. So the sort of the causality between the two things you should be very careful with. But that's at least, again, one way you can use these predictions is to look at how it relates to other types of policies. The final graph here, it's a little bit different, but here we're looking at things year by year. And we split the data into three groups. Again, you have the blue ones with the large effect, the red ones with the small ones, and the black ones with the sort of median effect. And you can see, and then we split it year by year. You can see on the left-hand side is what we talked about so far. Then we're looking at the labor earnings. There are no clear trends here. You can see in the financial crisis, 2009, the effects were larger, and in particular for those with also average effects that are larger, and that's what we would expect. But then when you go to panel B, you can see that these three lines over time kind of fan out. If you look at in the first years, you can see that despite these very large differences in effects on labor earnings, there are very small differences in terms of the impact on disposable income. And that's because that in those earlier years, the level of insurance was very high, right? In particular for those with the large effects. But if you go to the final period, it has the level of insurance has eroded, which is general well-known fact in Sweden. But what we can show here is that this affects particularly the people with the large gross earnings losses. So essentially the changes in the insurance systems have not played a big role for the impact on disposable income at the top, but it has played a big role for the people at the bottom. So towards the end, the level of insurance is roughly the same across the three groups, around 50%, whereas in the beginning, there were very large differences. So, of course, you can also use these types of tools then to dig down into seeing which types of policy instruments are more targeted towards the people with the large losses and so forth. And that's something that we probably will do, but haven't had. We can't really do it within this paper because it's going to bring us too far. Okay. So I think I'm kind of out of time, and I showed you the results, and the interpretation is not adding too much on top of that. So maybe I'll leave the last -1 minute for if there are any remaining questions.
So there are two questions. So one is maybe minor. So when you showed these plots, do you fix other covariates to some values? Or these are aggregate? Because you could think of it as marginal.
So we haven't done this. So there's one thing we do that's in the appendix of the paper, which you can find online, where we look at sort of partial effects, but there we're not fixing things at their medians because we think there's a lot of heterogeneity that's coming from interaction. So instead, what we do is that we take the full distribution of all the other variables, and then we characterize workers, industries, and markets separately based on the what you would get if you impose the full distribution of the other covariates. And then so in an industry with a large effect from sort of arising only from the industry characteristics is one where if you would take those industry characteristics and impose it on everyone who was displaced, and then you get a big effect, then that would sort of tells you that, okay, this is a generic thing from the industry. And then we do the same for locations. It became a little bit complicated and didn't add too much to the interpretation. So it's kind of deferred. But if you're interested in that, it's in the paper.
So another question is, you mentioned industry and location are very important drivers of heterogeneity here, right? So did you check in the data whether people actually, like, what are the long and short run actions of individuals? So do they change industry and location, or what are they doing so that the earnings recover faster or slower? Did you try to figure that out?
That's a great question, and we actually do have. I think again, it's relegated to the appendix, an analysis of moves, and they do make sense in the sense that people move more if they are displaced in a bad place, okay, or a bad industry. Okay, and they move to better ones, so that makes sense. But in particular for the regional mobility, it's not a very big thing because people actually don't move that much. So that's why we kind of didn't make a big thing of it in the end because there are too many results anyway. But we do see that the mobility makes sense, but yeah, people are really reluctant to move. They move more if they're displaced than if they're not displaced, and they move in a sensible direction, but it doesn't seem to be a huge margin. Of course, changing industry more so, because, when you're displaced at the very granular level, people go into a similar firm in a different industry, but even at the sort of one-digit level, so manufacturing, blah, 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 people do change industry much more than location.
What about occupations?
Yeah. So we haven't looked at occupations here. So that's something we could do. It's a little bit tricky with the data that we have for reasons that maybe will take us too far. But we don't have full coverage in high frequency occupational data here. So it's a bit of a rolling panel-ish type of thing. So it's a bit trickier, but it's a sensible suggestion.
I think Andre wants to ask. Please, Andre, go ahead.
Thanks. It was a very interesting presentation, and to just add on the location thing that you mentioned, also related to the literature of 80 and investment students. There is literature naturally on interference. And when you analyze locations, would it be possible that those locations could have some spillovers or interference effects, which are commonly studied? And this naturally complicates, like you mentioned, additional. But is there any way to maybe consider this framework?
Yeah. No, it's a good point. So the only way we deal with it at the moment is very simplistic in the sense that we have done robustness checks where we excluded very large closures, where you would think that it kind of corrupts the whole market and things. But there are results here that actually suggest that this may be part of the process. So one of the things we find is that it's not necessarily the case that it's worse to be displaced from a large firm, but it's definitely worse to be displaced from a firm that's a larger share of the local market, right? So in that sense, suppose that you have a firm with 50 people and it's the only firm in this industry and this location, and then you're displaced, and you have all these people out competing for the same, non-existing jobs in that particular market. So everyone has to make some kind of change in one. Then it's bad. But if there are lots of similar firms, then it's, it's okay, even though it's not good. But so there's stuff that's kind of pointing in this direction. But apart from just making sure that the basic predictions are not influenced by very large events, we haven't addressed it. But for sure, it's something we could work more on.
Okay, thanks.
Thank you so much, Oscar. I don't have any more questions. It was a very interesting talk. Thanks a lot for joining, and I hope to see you in the future, also for upcoming seminars.
Yes, thanks. It was thanks for inviting me. This was great. Yeah.
Thank you.